Hello and welcome to space. We trust satellite navigation systems to guide us on the route, politely announcing the turns to make until we reach our destination. But the full potential of such systems is much broader. As we'll see here at the Danish Air Ambulance base in Billund, satellite navigation can be a true lifesaver in the sky.
An alarm sounds, an action call for the air ambulance crew. Somebody in the area needs to be airlifted to hospital as quickly as possible. The crew remain calm, but they waste not a second of time. Their air ambulance has just 5 minutes to take off, even if the weather conditions aren't perfect.
As we are in Denmark, bad weather is a big issue. We have a lot of rainy days, a lot of days with fog and mists and low cloud seeding.
This service, operated by the Norwegian Air Ambulance in Denmark, is the first to use a new European satellite system that makes it safer to fly in low visibility. Before, around 10% of missions had to be cancelled due to bad weather. That's 300 incidents a year in Denmark alone.
If we didn't have a satellite signal, we weren't able to bring the patient to the hospital, and therefore the patient wouldn't get the right treatment. For the person who gets the pre-hospital care and are flown to the hospital, it's a matter of life and death.
The EGNOS satellite service provides accurate positioning, vertical as well as horizontal, so a pilot can rely less on visual clues and more on the instruments. That makes it less of a problem if the ground is obscured by fog or clouds.
Now with the new EGNOS system, which is much more accurate than the normal GPS system, and we're able to get closer to the ground and be able to fly in weather that is with lower clouds or lower visibility than we are used to.
EGNOS is based on geostationary satellites and a network of ground stations that constantly correct the GPS signals, which on their own can miss a user's position by as much as 5 meters. The corrections are then relayed in real time to the EGNOS receivers in helicopters, planes or other vehicles.
What we have here is we have a Garmin GPS, which is able to receive the EGNOS channel as well. So what we can do is that we can load a procedure to the hospital in Aarhus. We see here we have the EGNOS channel shown down here. After that's loaded and confirmed, we can make the autopilot fly the whole GPS approach, and that gives us the ability to come from a high altitude in the clouds and down to a surface.
EGNOS positioning data is free to use for anyone equipped with the receiver. Pilots just need the approach procedures for various landing spots, which are developed by air traffic authorities and stored in the onboard computers.
Of course, there are costs involved in establishing the procedures, but as far as I'm concerned, we don't have any cost associated with using EGNOS.
Passenger planes can take advantage of this satellite system to safely land at airports not equipped with ILS, the instrument landing system, which uses costly radio-based equipment on the ground.
What's interesting with satellite navigation and with EGNOS is it can replace some means of approach needed at airports. So we can make savings at airports in terms of local infrastructure.
EGNOS is a joint project of the European Space Agency, the European Commission and the Eurocontrol agency that tests air traffic innovations at this centre. How could this type of satellite navigation ultimately make travel easier for regular passengers?
EGNOS can provide a more efficient service than we had in the past, including improving access to certain airports in adverse weather conditions. So better punctuality, fewer delays, less diversions to alternative airports.
So far, less than 10% of all flight crews in Europe say they're set up to use EGNOS. The Swiss Air Rescue Service has equipped all its copters with the new technology and trains all its pilots to use it, anticipating a nationwide adoption of EGNOS.
we need that accuracy because of the terrain. We're getting very close to the mountains, and that's why we need a very accurate satellite system, and also not only accurate, but also reliable.
In Switzerland, hospitals are to be made accessible for EGNOS-guided approaches. Victims of skiing accidents, for example, will be able to get help quickly, even if there's thick cloud, like in this simulation.
We did a lot of test flights. We have a collaboration with the Swiss Air Force, and we have installed in several helicopters from Rega and from the Swiss Air Force a tool that was calculating the precision and the reliability of the GPS and the EGNOS system. And that's for our purpose, it's accurate and reliable enough.
EGNOS, Europe's first endeavour in satellite navigation, can be used alongside GPS and also alongside Galileo, Europe's global positioning system.
EGNOS complements GPS and also complements Galileo, providing an additional boost to these systems. It's able to correct their signals and improve their performance.
Taking off in any weather, precise satellite navigation can give pilots better vision to save people in distress.
More accurate GPS, it's all going to be more beneficial for everyone in the end, also for the patients. And that's what we're here for, to help as many people as possible.
And now to our regular update on ExaMars. The spacecraft is traveling to Mars right now on a mission to search for signs of life. When it gets there in October, it will send a small test probe to make Europe's first ever controlled landing on the red planet. Vincenzo Giorgio, a key engineer behind this project, explains how it's done in this month's episode of Destination Mars.
Coming towards Mars at a speed of 26,000 kilometers per hour, we encounter the atmosphere of the planet. The system heats up. We're landing while braking. We keep braking until we slow down to 2,500 kilometers per hour, at which moment we deploy the parachute. The parachute helps us slow down further, but at a certain moment we turn on the radars. We know how far we are from the surface, so we deploy our platform. Our platforms start to stabilize autonomously thanks to the 9 engines, with retro rockets working until it reaches the ground. This is the moment we turn off all the engines and land. We are now on Mars.
That's all for now. Next month, we are looking at the latest experiments in space life support systems, including how to grow food in orbit. See you then.